Hi, welcome back to the computer computer network. Today we're gonna talk about chapter 3, transport layer. Chapter 3 outline. We have a four topic about chapter 3. The first one is introduction, and number 2 is a transport layer protocols. Number 3 is user datagram protocol. Number 4 is the transmission control protocol. Okay, we introduce general service we normally require from the transport layer, such as process-to-process communication, addressing, multiplexing, overflow, and congestion control. We discuss general transport layer protocols such as stop and wait, go back and selective repeat. We discuss UDP, which is the simpler of the two protocols we discussed in this chapter. We discuss TCP service and feature with ensures performance as connection-oriented service to users diagram. Finally, we discuss fraud order and congestion control in TCP protocol. The first one, introduction. The transport layer provides process-to-process communication between two application layers. Communication is provided using a logical connection, which means that two application layers assume that there is an imaginary direct connection through which they can send and receive messages. This is a picture of a logical connection at the transport layer. Next, transport layer service. As we discussed in chapter 1, the transport layer is located between the network layer and the application layer. The transport layer is responsible for providing service to the application layer. It receives service from network layer. In this section, we discuss the service that can be provided by transport layer. In the next section, we discuss several transport layer protocols. Okay, process-to-process communication, addressing port numbers. ICANN, ICANN range well-known ports, registered ports, dynamic ports, encapsulation and decapsulation, multiplexing and demultiplexing. Okay, flow control, pushing or pulling, flow control at transport layer, buffers, error control, sequence number, acknowledgement, and the combination of flow and error control, silent window. For network layer versus transport layer, and the further process-to-process communication. Process is an application layer, entity running program, the network layer, computer level, host-to-host communication. This is for image. Port number. Addressing port number, multi-user and multi-programming. The local host, local process, remote host, and remote process. the local host and the remote host IP address. The processor's port number 0 to 65, 535, 16 bits. The client program, the hypermode port number short life. Universal port number for a server, will not port number. The daytime client process on 52,000, but the daytime server process 13. IP address versus port number. IP address, port number, different rules in the section the final destination of data. The destination IP address the host amongst the different hosts in the world. The port number one of the process on this particular host. Internet Corporation for assign name and number. Well-known port assigned and controlled by ICANN. Register port register with ICANN to prevent duplication. Dynamic port never controlled nor register user as temporary or private. In Unix, the well-known ports are stored in the file called EGC services. We can use the script utility to extract the lines corresponding to the desired application. And SNMP stated in the chapter 9 use two port number 161 and 162, each for a different purpose. Socket address. A pair of socket addresses, the client socket address and server socket address. Encapsulation and decapsulation. The packet of the transport layer in the Internet user datagram segment packets. We refer to transport layer payloads as packets. Multiplexing and demultiplexing. Multiplexing many to one. Entity accepts an item from more than one source. Demultiplexing one to many. An entity delivers items to more than one source. Pushing and pulling. Flow control, balance between production and consumption rate, prevent losing. Pushing, the sender delivers items without a prior request from the consumer, and pulling, producer delivers the items after the consumer have requested them. Flow control at the transport layer. The sending process of processor, producer pushing. The sender transport layer, consumer and processor pushing. The receiver transport layer, consumer and producer receiving a process, consumer pulling. To buffer access of the memory location sending signal. Example 3.2. The above discussion requires that the consumer communicate with the producer on two occasions: when the buffer is full and when there are vacancy. If the two parties use a buffer with only one slot, the communication can be easier. Assume that each transport layer uses one single memory location to hold a packet. When this single slot in the sending transport layer is empty, the sending transport layer sends a node to the application layer to send its next chunk. When this single slot in the received transport layer is empty, it sends an acknowledgement to the sending transport layer to send the next packet. See later, however, this type of the flow control and full slot buffer and the sender and receiver inspector are error control at the transport layer. The sending and receiving transport layers. The receiving transport layer managed error control by informing the sending transport layer about the problems. Sequence number 2. The packets are numbered. The sending transport layer, which packet is to be resent, correct, lost. The received transport layer, which packet is a duplicate, same sequence number, which packet has a write-out of order gives the sequence numbers. Acknowledgement, positive signal packet arrived at safe sound. The receiver can discard the corrupted package. Checksum, the sender can detect lost packet using timer and resend it out of order packet. Each are discarded as lost packet and stored on once arrives. Silent window in circular format. Picture. Silent window in a linear format. Combination of flow and error control. Flow control, the use of two buffer. Error control, the use of sequence and acknowledgement numbers. Two requirements combined by two numbers buffer. Congestion control, router and switch buffer, the mechanism and technical that control the congestion and keep the load below the capacity. Connectionless service. Independencies between packets, no flow control, no error control, no congestion control. Connection-oriented service. Dependency between packet, flow control, error control, congestion control. Connectionless and connection-oriented service represent as SSMS. Summary: the main duty of transport layer protocol is to provide the process-to-process communication. To define the process, we need part number. The client program defines itself with an ephemeral part number. The service defines itself with a well-known part number. To send a message from one process to another, the transport layer protocol encapsulates and decapsulates message. Flow control balances the exchange of data items between producer and consumer. A transport layer protocol can provide two types of services: connectionless and connection-oriented. And connectionless service, the sender sends packet to the receiver without any established in a connection-oriented service. The service first needs expression connections